Hello my dear students, welcome back to Power System class. I hope all of you are doing well. In previous class, we visited solar power technology and different types of solar collectors. So just a quick review. There are two types of solar collectors. First is non-concentrating, another one are concentrating. And in non-concentrating, we have flat plate collectors, and in flat plate collectors there are basically two types of collectors. First one was liquid flat collector and another one is flat plate solar air collector. Okay, then we have discussed concentrating solar collectors, and in that we have four types: parabolic throw, power tower system, parabolic dish, and Fresnel reflector system. We have discussed parabolic throw system yesterday, and today we will be starting with power tower system and rest of the systems. Okay, so here in the figure you can see the diagram of power tower system. These rectangular boxes you are watching are nothing but mirrors. We also call these mirrors heliostats. Okay, and here's a receiver which is placed on top of the tower. Okay, here you can see these are, let me, so these are nothing but mirrors. They call them heliostats, we will call it mirrors. And here is the central receiver. Okay, and because of that, this power tower system is also called central receiver system. Okay, now coming towards the construction of the system. So what do we have in here? We have large flat mirrors. They are not curved, as you can see they are flat mirrors, and they are distributed over an area. Okay, over the area of a ground, and these mirrors are dual axis tracking reflectors. Okay, so वो लोग क्या करते हैं, जो सनलाइट आती है उसको रिफ्लेक्ट करके वो लोग, ये सारे मिरर्स क्या करते हैं, रिसीवर की तरफ सनलाइट को डायरेक्ट कर देते हैं. ओके, एंड देन ये जो रिफ्लेक्टर्स है उनको एडजस्ट किया जा सकता है so that they can track the orientation of sun. Okay, so टावर जो है उसको अपना ओरिएंटेशन या खुद का ओरिएंटेशन चेंज नहीं करना पड़ता. ये जो मिरर्स है वो इस तरह से एडजस्ट होते हैं कि जो सन की जो रेज है वो उनके ऊपर 90 डिग्रीज पे 90 डिग्रीज पे इम्पैक्ट करे, एंड देन they tilt in a manner that all all the all these rays gets concentrated on central receiver tower. Okay, so how does this thing works? तो रिसीवर जो होता है वो इस टावर के ऊपर होता है. दिस थिंग इज अ रिसीवर एज यू कैन सी, एंड इन मिरर्स के ऊपर जो सोलर रेडिएशंस गिरती है वो रिफ्लेक्ट होके कहाँ पे जाती है, रिसीवर टावर पे. ये सभी मिरर्स सन रेडिएशन को कैप्चर करके कहाँ पे भेज देते हैं, सेंट्रल रिसीवर के पास. और ये जो सेंट्रल रिसीवर है, जो वी आल्सो कॉल इट सोलर पावर टावर. सो वो क्या करता है, ये सारा रेडिएशन जो है वो क्या करता है, रिसीव करता है. और देयर इज वन मोर थिंग कि रिसीवर के अंदर जो एक फ्लूइड होता कोई फ्लूइड होता है, ठीक है, एंड इट्स गेट्स हीटेड बिकॉज ऑफ दिस कॉन्सेंट्रेटेड सनलाइट। ओके, और ये जो फ्लूइड जो हीट हुआ तो उसमें से क्या होता है, हीट एनर्जी प्रोड्यूस होती है, और मतलब हीट एनर्जी प्रोड्यूस होती है और हाई टेम्परेचर प्रोड्यूस होता है। सो दैट फ्लूइड गेट्स कन्वर्टेड इनटू स्टीम, and that steam we use that steam we use to run the turbine, and turbine is coupled with my generator, and as the turbine will move, generator will also move, and electricity will be produced. Okay, so what's the best application of it? That we can use it in the cloudy days as well, right? If we just when the sun is out, what we will do, we will collect collect all the radiation, we will give it to receiver, and what receiver will do, receiver will convert that fluid into steam, and we will store that steam. So when sunlight will not be available, we can use that steam to run the turbine and obtain energy. Now let's jump to the next system. We call it parabolic dish system. So here in the figure you can see the arrangement of parabolic dish collector system, and how does it look. It looks something like this. So you all may have seen such kind of dishes in your cable operating devices, Tata Sky, Dish TV or Airtel. The shape and appearance of these dishes are a little similar to them, just little more larger. Okay, so here you can see we have a large reflector over here, and we have receiver over the dome which will receive all the radiation. Okay, so our system has a focus collector point, or we can call it a concentrator. Okay, which is parabolical shaped in the form of dish, the form of dish. And what it will do, what it will do, it will receive all the solar radiation and reflect it onto the receiver, which is mounted to the focal point. Okay, here focal point. So here's one thing which is noticeable, that we have focal point in this system. Okay, then the reflector here, it tracks the sun into two axis, और उसको कहाँ पे माउंट किया गया होता है, on this structure, we call it M structure. Okay, and it has modular collector and receiver units. And what is the speciality of parabolic dish system, कि ये जो कलेक्टर होते हैं उनका कंस्ट्रक्शन इस तरीके से होता है कि जिससे वी कैन अचीव हाईएस्ट concentration ratio. Okay, now coming towards the working of this system, how does it work? So ये जो parabolic dish है हमारी, what it will do, it will collect all the solar radiation of the sun, and it will capture the maximum solar energy. Okay, and then that radiation, it will focus that radiation onto that one focal point or receiver or absorber, जो भी आप बोलना चाह रहे हो, ठीक है. और वो जो हीट है, जो हीट यहाँ पे कलेक्ट हुई है ऑन अ फोकल पॉइंट, what will happen with it? It will get converted into electricity with the help of heat engine generator assembly. Okay, जो रिसीवर के साथ कनेक्ट की गई होती है. नाउ ये सिस्टम जो है वो फ्लेक्सिबल है. एज यू कैन सी वी हैव डिश एंड you can you can move it around in various directions, so it is flexible. And इसको the most unique quality of such system is we can use it for large scale as well as small scale. Okay, because basically it depends on the size of our dish. If you are using large scale, if you have application of higher power, you will use large scale. If you have application of lower power, you will use small. Okay, so that was our parabolic dish system. Now next up is Fresnel reflector system. Okay, so just on right of our parabolic dish system, you can see Fresnel reflector system here. Here are Fresnel lenses. They are nothing but just ordinary mirrors. I will be explaining what are they. Then we have incident ray, reflector ray, and receiver. Like incident ray is the ray that comes from the sun. Like uh, imagine here's the sun, so incident ray will come from the sun to my mirror like this. Okay, and this is the same ray but reflected towards the receiver. Okay, towards the focal point. Get it? So this Fresnel reflector system, उसका नाम कहाँ से आया? It was named after a French physicist, Augustine Jean Fresnel, and उसके ऊपर से we call it Fresnel lens. Okay, so you can see ये जो mirrors हैं यहाँ पे, they are linear mirrors. Okay, so how do we construct them? We can construct them by substituting our parabolic draw in linear segmentation. Okay, and what they do, they focus the solar radiation on a focal line, as you can see, just like that. And what are they made of? They are made of nothing but simple flat mirror segments. Take a flat mirror and distribute it in different small segments, and then by that way we make this Fresnel collectors. Okay, and जो focal point होता है वहाँ पे receiver is mounted. Okay, now how does this work? So जो Fresnel reflector होता है वो क्या करता है? It uses thin long mirror segments which focuses sunlight onto a receiver at a common focal point. So what do this mirror do? They receive the sunlight and they focus on this point, and ये जो हीट एनर्जी है जो यहाँ पे जो कॉन्सेंट्रेट होगी एनर्जी, उससे जो हीट जनरेट होगी रिसीवर पे, वो कहाँ पे ट्रांसफ़र हो जाएगी? वो हीट एक्सचेंजर में ट्रांसफ़र हो जाएगी. ठीक है, एंड हीट एक्सचेंजर विल ड्राइव द टर्बाइन, and just like our parabolic dish system, turbine will be coupled with generator and generator will rotate and electrical energy will be produced. Now coming towards the advantages of CSP, concentrating solar plants. So firstly, हाई डिलीवरिंग टेम्परेचर और एफिशिएंसी जो है उसकी काफ़ी अच्छी होती है, ठीक है। हीट लॉस एरिया जो है कम हो जाता है। देन रिफ्लेक्टिंग सरफेस मटेरियल रिक्वायरमेंट इज लेस देन फ्लैट कलेक्टर। ओके, फ्लैट कलेक्टर में यू नीड अ लॉट ऑफ सरफेस। ओके, सो सरफेस मटेरियल रिक्वायरमेंट जो है इज वेरी लेस, एंड इट कैन स्टोर हीट एनर्जी, हीट at high temperature with help of energy storage system, which was not the case previously, right? And then it can be used for power generation, not only power generation but in the heating applications as well. But again, these systems also has disadvantage. So what are the disadvantages? The major main disadvantages that we are using either lenses or we are using mirrors, and if you use mirror or lens of such big size or shape, then it will be costly to you. So initial cost is very high. Again, you are using lenses and mirrors, so you have to keep them clean, so maintenance will be high, and it is necessary to have a receiver with a tracking system in order to track the sun. So you will need a tracking system. So that was our solar collectors. Now here they have given comparison of different solar collectors and comparison between flat plate and concentric solar collectors. I'm not going into detail of that. We have studied all four of them, all for concentrated, and all two of them in flat plate. So you can compare them. It should be pretty easy for you. So we are not going into details. We are just directly going to solar photovoltaics. Okay. So first thing is, solar photovoltaics is rapidly growing in India. You will see that there are so many places where solar plants are established and they are working on solar panels and a lot of various solar applications, right? So सोलर का कैपेसिटी कितना है? पहले 2018 तक इट वाज अराउंड 21 गीगावाट, अभी तो काफ़ी ज़्यादा बढ़ गया है, ठीक है। एंड रिन्यूएबल एनर्जी इंस्टॉलेशन कैपेसिटी का यहाँ पे एक टेबल दिया हुआ है जहाँ पे आप देख सकते हो विंड का बहुत ज़्यादा है कंपेयर टू ऑल अदर एनर्जी सोर्सेज, एंड सोलर का कितना है? 21,651.48 मेगावाट। ओके, सो इंडिया का टोटल ग्रिड कनेक्टेड पावर कितना है रिन्यूएबल में? ओनली आई एम टॉकिंग ओनली अबाउट रिन्यूएबल। ओके, सो इट इज़ 69,022.39 megawatt. And if we include both renewable and conventional sources, which are your conventional sources? Again, थर्मल एनर्जी हो गया, न्यूक्लियर एनर्जी हो गया, डीजल प्लांट्स हो गए, हाइड्रो पावर प्लांट्स हो गए। ओके, सो दोनों का कंबाइन करके आपका इंस्टॉलेशन पावर कैपेसिटी है 344 वाट गीगावाट्स। ओके, जिसमें से रिन्यूएबल का कितना है? 69.022 गीगावाट। ओके, एंड एज यू ऑल ऑलरेडी नो दैट कि कन्वेंशनल जो हमारे फ्यूल्स है, वी आर रनिंग आउट ऑफ our conventional fuels. We will be running out of our conventional fuels really soon, like petroleum हो गया, and there are other sources like thermal power plants. But इन सभी sources में क्या होता है, in one way or another pollution बहुत ज़्यादा होता है, and by using renewable energy we can avoid it. Okay, so now we will start photovoltaic system. So what is photovoltaic system? If I have to give a definition in simple words, so it is nothing but a system which will convert my solar radiation, or which will convert my sunlight into electrical energy or electricity with the help of semiconductor materials. Okay, so, and which semiconductor materials? The materials which exhibits photovoltaic effect, silicon, germanium, etc. Okay, then we will discuss what is solar cell, solar panels and arrays. So सोलर सेल क्या होता है? इट्स नथिंग बट अ सेमीकंडक्टर डिवाइस जो क्या करता है, इलेक्ट्रिकल एनर्जी को सोलर एनर्जी को इलेक्ट्रिकल एनर्जी में कन्वर्ट करता है, सोलर एनर्जी को डीसी इलेक्ट्रिकल एनर्जी में कन्वर्ट करता है विद द यूज ऑफ फोटोवोल्टेइक इफेक्ट. नाउ सोलर पैनल क्या होता है? इट इज नथिंग बट कलेक्शन ऑफ मल्टीपल सोलर सेल्स. Okay, so here you can see when number of solar cells are connected together to increase the utility, that assembly is called module या फिर panel. Okay, and we have seen previously एक solar cell कितना volt produce कर सकता है? Does anyone remember that? Around 0.5 to 1 volt. Okay, so here we are producing 12 volt and we are having 36 cells connected into the series manner. Now what is solar array? So it is nothing but an arrangement of my solar panels, different arrangements of my solar panels in order to obtain desired voltage. So to achieve the desired voltage and current rating, panels are wired in series and parallel combination, that is called PV array. Now coming to discuss the schematic layout of solar power plant. Okay, here you can see here's my solar array, PV array. So what it will do, it will generate DC output. We will use MPPT, maximum power point tracker, and we will convert that fixed DC into variable DC. Then we give this DC to AC converter. In that, what it will happen, it will convert my DC into AC, and then we can supply this AC power to the grid or AC load whenever you want to send. Okay, so we can use them as a we can use as a standalone as well as grid. Okay, you can see here we are using it as a standalone for AC grid, and then we are using it for connected grid. Okay, and this PV generation systems employs solar panels made up of number of solar cells. Remember, we just discussed few seconds ago, with photovoltaic material. कौन सी चीज़ें इसके अंदर इन्वॉल्व होती हैं? इट हैज़ फोटोवोल्टेइक मटीरियल, इट हैज़ बैटरीज, वन और मोर देन वन बैटरीज. इसके अंदर होता है चार्ज कंट्रोलर, इन्वर्टर एंड माउंटिंग हार्डवेयर या फिर फ्रेमवर्क, जो भी बोलो आप, एंड an MPPT system, tracking system. Okay, and what is the voltage of battery set? It is generally 6 to 12 volts. Okay, और कौन सी बैटरीज यूज होती है? लीड एसिड बैटरीज यूज होती है. Got it? Now solar PV output is DC electrical energy, and for grid connected solar photovoltaic system and for AC load, inverter is used, which will convert DC energy into AC energy. Okay, that's what inverters are used for, to convert DC energy into AC energy. Okay, then your charge controller, which is used for overcharging or अंडर डिस्चार्जिंग. ओके, बैटरी के ओवर चार्जिंग या अंडर डिस्चार्जिंग को अवॉइड करने के लिए हमको चार्ज कंट्रोलर का यूज़ करना पड़ता है. वो क्या करता है? करंट का फ्लो जो है वो मेंटेन करता है बैटरी में. ओके, एंड लास्ट बट नॉट लीस्ट, MPPT सिस्टम, मैक्सिमम पावर पॉइंट ट्रैकिंग सिस्टम. जिससे हम क्या कर सकते हैं, हम लोग जो सोलर पैनल है उसकी एफिशिएंसी कैलकुलेट कर सकते हैं विद द हेल्प ऑफ दिस एमपीपीटी सिस्टम. So we will keep our lecture till here, and we will be visiting different types of solar photovoltaic power plants in upcoming lectures. So thank you very much for listening, everyone. I will be seeing you in a very next lecture. Bye bye. Thank you.